Hello everyone, welcome to this video. In this video, we'll be solving this question which states that if R is any fixed rotation and F is any fixed reflection in a dihedral group, then you need to prove that R raised to power k, F R raised to power k is equals to F. This thing is we have to prove, right? So here, in order to prove this thing, we have two ways to do that. One is the natural way. If you remember, if we take rotations as even and reflections as odd, so our result is again odd quantity. Remember this result? So using this result here onto this left hand side of the given quantity which we need to prove, we have R raised to power k, F R raised to power k. This could be written as, you can extract 1 R from here, right? So it would be R raised to power k minus 1 into RF into R raised to power k. Correct? Now what is this RF? This RF is F, right? And again, what you can do, you can extract 1 R from here, right? We can again club up these terms from here. We can extract 1 R from here, so that it would be FR. Again, reflection into rotation is what? It is again reflection, right? So we have reached from here to here, correct? Similarly, what we can do, we can again extract 1 R from here, so that we would have R raised to power k minus 1, and that R can be clubbed with this F. Again, rotation into reflection is reflection, so this R is also absorbed here. Now again, what we can do, we can again extract 1 R from here, so that it would be R raised to power k minus 2, and 1 R is here. Again, reflection into rotation is reflection. So you see, in this manner, all the R's, they are absorbed by this F. So ultimately we'll be reaching at a point where we would have just RFR. So what would be this RF? It would be just F, and what would be FR? It would just be F. So you see, finally we are reaching at F. This is a natural way to see up the things, right? However, we are studying abstract algebra, so we need to provide abstract proofs, correct? So in order to have an abstract proof, let's see how we can reach at this result that R raised to power k, F R raised to power k is equal to F. We already know that any rotation composed with any reflection is a reflection, right? So that means F into rotation raised to power k, which is again some reflection in Dn, right? Why? Because each R would be absorbed herein. And moreover, you know, when you apply any reflection twice, it would be the original position, which is the identity of this group Dn, which is R0, rotation by 0 degree. Hence, you can say any reflection that is the inverse of its own, correct? So let's mark this as equation 3. Now using this fact here that F R raised to power k is Fi, we would have F R raised to power k, F R raised to power k as equals to the identity, correct? So therefore, this what we can do, we can pre-multiply both sides with F inverse, so that this quantity would become R0. So we would have R0 here, and here it would become F inverse. And using the above result, because you know the inverse of any reflection is that reflection itself, so we have F here, and this is what we wanted to prove here in this particular case. So I hope you understood this proof well. Well, that is it for this video. Thank you for watching.